Okay, we're going to be moving on to trigonometry now. And the most basic aspect of trigonometry is you're going to need to know what theta is. Thetas are written out like this, theta, or it's this symbol here. And usually we put theta in for a different or an angle, so we can calculate different sides or lengths or sides. Yeah. So there are three main components when you want to calculate. There's the hypotenuse. There's the side that's adjacent to the theta, the one that's close adjacent, and then there's the opposite, as in the opposite side. Okay, then we move on to the functions. Most of you have probably seen sine, cosine, and tangent before. When you calculate it, you want to calculate using the opposite over the hypotenuse. So that would be over here. You would use the opposite side divided by the hypotenuse. So for example, you get a number here and a number here, and you just apply them into the function. And then there are three new ones. That's cosecant, secant, and cotangent. Basically, they're just the opposite of, for example here, cosecant is the opposite of sine. As you can see, hypotenuse over opposite.
Let's move on to finding lengths of a triangle. There is a simple equation for this. You might remember it from a different math class, but if not, that's okay. It's a squared plus b squared equals c squared. If you're wondering what a, b, and c are, this little diagram here will help you. A and b are the legs of the triangle, so this leg and this leg, while c is the hypotenuse. C will always be the hypotenuse and A and B will always be the legs. It doesn't matter which leg A and B are because they will, just adds up to the hypotenuse. But the hypotenuse will always be C. Here's an example of a ski lift. Now we are going to find the distance from the mountain right here, this huge thing, and the ski lift up and down. So see, we're finding this distance. Ski lift to the, here and here. It's basically what we're finding, right? So the distance from here to here, where the hill begins to, slope upwards, is 6. And the distance from here to here is 4. So we can use the formula that I told you. Remember? A squared plus b squared equals c squared, right down here, right? So we're going to use that, and we're going to figure out the distance between here and here. So a squared, so 4 squared, let's say, that's 16, right? Plus 6 squared, which is 36, is equal to 52. Okay, so the distance from here to here is 52. Woo! We found it! Yay!
The first type of triangles is called the 45-45-90 triangle. The opposite and adjacent legs are equal to 1, and the hypotenuse is equal to root 2. And when you add up all of these three angles, you will get 180 degrees. The second type of triangles is called the 30-60-90 triangle. Across from angle 60 is root 3. Across from angle 30 is 1, and the hypotenuse is equal to 2. And when you add up all these angles, you will get 180 degrees. The question asks us to find the values of x and y. Since it's a 45-45-90 triangle, we know that the opposite leg is equal to the adjacent leg. That means x has to equal to 7, and the hypotenuse has to equal to 7 root 2. So x is equal to 7, and the hypotenuse is equal to 7 root 2. This question is asking us to find the value of y of a 30-60-90 triangle. To find the value of y, we can use sine. So sine of 30 is equal to 6 over y. And whenever you have the value of the variable on the denominator, you can always switch it with this value. So 6 is divided by sine of 30, which equals 12.
Okay, if we look here at this ginormous, impressive tree, we're going to try and find the hypotenuse of the triangle that we see here. With the triangle. So the distance from the base of the tree to my body is displayed right here. And the height of the tree is displayed right there. Okay, so what we need to do is we need to find the hypotenuse. Now there are multiple ways to find the hypotenuse. Okay? You gotta prepare yourself. So the first way is, like Adele explained, is to use a squared plus b squared is equal to c squared. So we take this, we take that, and we find c squared using the magic of math. The other way is to use trigonometry. We take this over this, and we find the hypotenuse using the magic of math. What we can also do is we can find the angle of this corner and that corner. And the way we do that is we use our trigonometry again, and we just equal it to the side that's closest to it, or the hypotenuse, or the opposite. It really doesn't matter. You can just pick what you want, type it all into a calculator, you're good. I'll explain that later. So, progressive tree, triangles, hypotenuse, it's good. It's all good.